All right, here is our last question. This is a classic one. Like if you Googled this, you would definitely find this question on Google. But it's a good one because it calls back to our understanding of vectors and lets us use them to like really show off that projectile motion is pretty simple from a mathematical point of view, even if it does seem like it's a lot of steps right now. So we have a physics student throwing a ball along a parabolic trajectory. I drew it in here the way that it's drawn in the classic question that comes out of like uh, a book called Five Easy Lessons and probably other places too. So I drew it in the way that it would appear. I just wrote it in the sketch area. And then it gives you some of the positions and velocities. And the velocity that it gives us, instead of a value in meters per second, it gives us to it in that IJK notation or that vector notation. So it's asking, what is the value of G on planet Exeter? And looking at this question, the first instinct is that this question is really, really hard and that you weren't given enough information. But in reality, actually, we were given a lot of information just based on how it's drawn here. So the first thing that I'm going to do is I'm going to look at these other two positions, and we're going to realize that we actually know the velocities at those two places. The velocity at this place has to have, it's the highest point, so it has to have 0 in the j direction because we're at that highest point. But the horizontal velocity still has to be 2I because the horizontal velocity is always the same. So we know the velocity at, vector for that one. And we also know the velocity vector at the next point. At the next point, the horizontal velocity is still the same. It's still 2I. Oops, didn't want to do that. But since it's at the same height as the 1 second, it's on just 1 second the other way. That means that by now, the acceleration has done exactly the opposite thing that happened to the 1 second vector. So if the 1 second went from 2j to 0, now we're going to go from 0 to negative 2j. It has the same magnitude of the velocity, just opposite in direction. So that gave us a lot of information. And I'm actually going to use only two. This gave us more information than we needed. I'm going to use only two of the places to solve my whole problem, two time intervals. I'm going to use right here to solve the whole thing. And that means that the time that I'm using is just a 1 second interval because it goes from 1 to 2, so that's 1 second. Based on that, I actually don't know any of this stuff. No vertical position information is given on the graph. I didn't write anything about units anywhere, and they're not given in the original problem. But what I know is that in the vertical direction, I have a vertical velocity of 2I meters per second and a final vertical of 2I meters per second, and my acceleration is 0 meters per second. In the vertical direction, I hope I've been using horizontal and vertically correctly. I still don't know anything about what's happening in the positions, but I know that the y is going to be at my first moment, my initial, it's 2j, and at my final, it's 0j, and my acceleration in this case is what I'm trying to figure out. So I can solve this one here. I want to figure out acceleration. I know nothing about position, which means the equation is very easy to choose. It has to be that first one. So my velocity in the y direction is going to be equal to v naught y plus my acceleration times time. I know this information. I know this. Let's see, that's going to be 0. So I just end up with something that looks like 2j, that's my velocity vector, plus ay times 1 equals 0. And then I can just subtract 2j from both sides. That's 2j from both sides equals ay. And we find out that we have a surprise, surprise, negative acceleration. And the quantity of it is -2 in the y, in the -2 in the y direction. That's what that j vector means. So because we aren't told any other information, well, actually, since this is a j vector, j is 1 unit. So this is actually -2 meters per second per second. Or yeah, negative 2 meters per second because J is just 1. It just represents in the Y direction. So actually, we know the exact value of G on planet Exodor. So super exciting. If you're ever asked at gunpoint at G point, that's another word that we don't use. If you're ever asked at G point what the acceleration, the value of G on planet Exodor is, you now know not just how to solve it, but you know the value off the top of your head. It's -2. So that's our last projectile motion example problem. Thanks for tuning in.